So in this video, we are going to be learning how to factorize quadratic expressions. Now, this is something that you really need to have a good grip on for two important reasons. One is that it's very important in the sense that this is something that's always tested in paper 1 and sometimes even in paper 2. And another is that it's also very easy, okay? So once you have a good grip on this, because like I said, it's easy, so it's easy to get a good grip on this, you're going to feel far more confident about attempting the paper. And this, since it's algebra, and algebra, as we know, is the backbone of O-level math, so this will help you be able to improve other topics also, because most of the topics at the end of the day, it just the solution to any question just boils down to how good your algebra skills are. Okay, so first of all, I want to tell you what the difference between an expression and an equation is. I'm sure you must have heard me say this a lot of times, but since we're doing quadratic expressions, it's important for us to emphasize on this right now. Okay, so an expression is something that really can't be solved. Okay, so if anyone for that matter asks you to solve an expression, that's completely incorrect. Okay, it's illogical. Okay, it doesn't make sense. It's contradictory basically. So reason behind that is that an expression looks like this: x minus 2. This is a linear expression, or it could be x squared minus 5x plus 6. This is a quadratic expression. Just like this, you can have a cubic expression, so on and so forth. So an expression, in short, does not have an equals to sign. Okay, so the max that you can do with an expression is that you can factorize it. Okay, or you may be asked to expand it. Obviously, you're not going to be asked to expand something like this. Okay, so you may be asked to expand something that looks like this: x minus 3 times, let's say, x plus 1. You may be asked to expand this. Okay, expand and simplify. Okay, so what that really means is expanding it basically means that getting rid of all the brackets. Simplifying means that finding all the, or collecting all the like terms and adding them or subtracting them, whatever it is that may be possible between the two. So that's what basically expand and simplify means. And you'll come across questions like these in paper 1 and in paper 2. So as I was saying, an expression is something that cannot be solved. An equation, on the other hand, is something that you can solve, and by the end of it, you will have a value of whatever unknown that you have in that equation. So for example, if I give you x minus 2 is equals to 5, this is a no-brainer. We can solve this and find out what the value of x is by taking minus 2 over to the other side and equaling it to 7. That means x is equals to 7. And that is why whenever you come across an equation, you will notice that you're either asked to solve it or you're asked to find the value of x, or find the value of whatever unknown that you have in that particular equation. Okay, so I hope that concept is clear for you guys. Maybe I'll make a detailed video on it, but it's not really that necessary. Just remember that an expression can only be factorized. An equation, on the other hand, can be solved. Okay, so we're going to focus on quadratic expressions, and there are essentially four types of actually, as far as quadratic is concerned, there are three types of quadratic expressions that you may come across. So I've highlighted them in green. And as far as factorizing is concerned, there is a fourth case. So I've written it over here. I'll highlight it in red for you guys. So this is different than a quadratic expression for obvious reasons, because the power is not 2. The maximum power that you'll find is 1. And I do have a separate video on expressions like these, but what I really want to cover in this video is basically how to deal with the first kind of expression, okay, which you might have heard of this as breaking the middle term, or middle term breaking, or something like that, something along those lines, something to do with the middle term. Okay, and this always surprises me that a lot of students in grade 9, 10, or even 11 sometimes struggle with middle term breaking. So it's something, if you're an 11th grader and you're watching this, so this is something you really need to have a good grip on. Anyway, so enough introduction, let's get straight to business. So we have x squared plus 10x plus 24, and we're going to factorize this. So the first thing you want to do is you want to make sure that the equation is written nicely. Okay, by that I mean that it's in an order where you have the term with x squared first, and then the x, and then the constant. Okay, so that's how it should be: x squared, x, and constant. Now there may come a point where you don't really have a term in x, so that in that case just x squared and then the constant. There may come a point where you don't really have a constant, so in that case just a term with x squared in it and then x. Okay, so the first thing you want to do over here is that you want to take your constant and you want to multiply it. Okay, So here's what I'm going to do. I'm going to take my constant, which is 24, and I'm going to multiply it by the coefficient of x squared, which in this case happens to be 1. So the second I do that, 24 times 1 is equals to 24. Now in the first column, I'm writing the product, okay? And in the next column, I'm going to be writing the sum, or which will always be the middle term, by the way, which is basically 10. Okay, so let me just write this nicely. So we have the product and we have the sum. So now what I'm doing is I'm basically looking for two numbers that I can multiply and make 24 and sum up to make 10. Okay, positive 24 and positive 10. Now I will be doing maybe a dozen examples. Okay, so if you're wondering why aren't we using the minus sign, or what happens if one of the terms is negative, so just hold on to that thought, because I will be covering that in the examples that I have lined up for you guys. Okay, so two numbers that I can multiply and make 24. So I'm going to start with 1 times 24, but that's not going to do me any good because 1 plus 24 equals 25, and I'm looking for 10. So nothing to worry about. Let's do a bit of trial and error. 2 times 12 is also equal to 24, but 2 plus 12 is not equal to 10, so not good enough, not good enough. 3 times 8, not good enough, because 3 plus 8 is equals to 11. That's not what I'm looking for. 4 times 6, however, does the job, because 4 plus 6 is equals to 10, and that's exactly what I'm looking for. Okay, so now how exactly am I going to break the middle term? Here's how I'm going to break the middle term. X squared plus 4x plus 6x plus 24. The next thing you want to do is you want to make pairs and take common. Okay, so pair means 2. So in this pair I can factor out x, so I'll have x plus 4 inside the bracket. In this pair I can factor out 6, so if I factor out 6 I'll have x plus 4 inside the bracket again. And one way to make sure that you've done this correctly is to see whether the two expressions that you have inside the bracket are the same. If they are, that means you're on the right track, you've done it correctly. If they're not, that means you have done something wrong, and it's always best to go back and check. Now, since we're asked to factorize this, this is the point where you stop, okay? And that's it. You don't have to say that x plus 6 is equals to 0 and then x plus 4 equals to 0 and then write down the values of x. That's absolutely irrelevant. If you do that, and if your examiner is someone like me, you're probably going to end up losing marks because you're going against what you were supposed to do or what you were asked to do in this question. Okay, now let's do another question over here, and now you have x squared plus 9x plus 18. So again, the first thing I want to do is I want to make a column. In the first column, I'm going to write the product of the constant and the coefficient of x squared. So that's 1 times 18, which is equal to 18. And in the next column, I want to write down the sum, which is basically the middle term, and that's 9. Okay. So I'm looking for two numbers that I can multiply and make 18. So we start with 1 times 18, which is not going to do us any good. And then 2 times 9, which again is not going to do us any good. And then 3 times 6, which will work because 3 plus 6 is equals to 9, and that's exactly what we're looking for. Okay, so what happens next is that x squared plus 3x plus 6x, and you can change the order, by the way. You can write x squared plus 6x plus 3x. It's completely fine as long as you're not messing with the signs. And then in the first pair, you can factor out x, so you get x plus 3. In the next pair, you can factor out 6, so you get x plus 3 again. And the fact that they're both the same means that you've done it correctly. And over here also, you can change the order. You can write x plus 3 first and then x plus 6. It makes no difference. But what's important is that you remember that this is the point where you stop. Okay. Now we have a third example. And this time you might have noticed that I've amped things up a little, because this time we have a coefficient of x squared, which is not 1, which is 3 in fact. And the constant is 8. So we get 3 times 8, which is 24. And the sum has to be 11 because that's what the middle term is. So we did factorize 24 earlier, and this time what we're looking for is that we're looking for 3 times 8. So 3 times 8 is equals to 24, and 3 plus 8 is equals to 11. So now here's what I'm doing: 3x squared plus 3x plus 8x plus 8. Okay. Now in this pair, you not only can you factor out 3, but you can also factor out 3 along with an x. So 3x, and then you have x plus 1. And then in the next set of terms, you can factor out 8. So you have x plus 1 inside the bracket. And again, x plus 1 inside both the brackets is evidence, means that we've done it correctly. So you have 3x plus 8 times x plus 1 as your final answer. And again, as I mentioned, this is the point where you stop. Okay, so now we have another example where you have x squared plus x minus 6. Now what's different over here is that the constant is negative, okay, so it's minus 6. So what I want to do now is, again, the method remains the same, that you take the coefficient of x squared, which is 1 in this case, and multiply it by minus 6. So what you end up getting is negative 6. So that's what your product is, and the sum you want to be equal to 1. Now I am going to make a little table, okay, which I want you to use, not all the time, but initially, so that you're able to decide where to put the minus sign. Okay, so this is something that I've started doing only recently, and it's turned out to be very helpful. So over here you write the product, over here you write the sum, and over here you write the minus sign. Okay, now if the product is positive and so is the sum, then where do you put the minus sign? Well, you put it absolutely nowhere. Okay, as we saw over here, the product was positive and so was the sum, so the minus sign was nowhere to be seen, and that's how it should be. If, however, the product is positive and the product is negative and the sum is positive, where do you put the minus sign? You put the minus sign with the smaller value. Okay, so I've written smaller here so that you remember where to put it. Smaller basically means smaller value. Okay, now what do I mean by that? So one way to get 6 is 3 times 2. Okay, but I don't just want 6, I want minus 6, so that means I need to put the minus sign somewhere. So this time I'm going to put the minus sign with the smaller value, which means, what just happened? Yeah, which means that the minus sign will go with 2. Why? Because that is the only way the sum turns out to be positive 1. Let's see what would have happened had I put the minus sign with 3. In that case, minus 3 times 2 would have still been minus 6, so we're checking that box, but minus 3 plus 2 is equal to minus 1, so that means we're not checking this box, the box where the sum is equal to positive 1. So now what do I do? Well, I break the middle term, x squared plus 3x, using these terms, x squared plus 3x minus 2x minus 6. In the first pair I factor out x, so I have x plus 3 inside the bracket. In the next pair I factor out minus 2, so I have x plus 3 inside the bracket again. Now whenever you have both terms as negative, it's important to factor out with the minus sign so that the two expressions can match. Had I not factored out with the minus sign, had I just factored out 2, and by the way, whenever I say factoring out, I mean taking common. So I would have ended up with minus x minus 3 inside the bracket, and the expressions don't match, so that means that's absolutely incorrect. I got to make sure that I factor it out with the minus sign, so that way I have minus 2 times x plus 3, and x minus 2 times x plus 3 is your final answer. Okay, so that was one question. I'm going to do two more questions of the same category for you guys. So over here we have minus 16, which we're going to multiply by the coefficient of x squared, which is 1, so we get minus 16, and the sum has to be positive 6. So two numbers that you can multiply and make 16, do a bit of trial and error. If you get it right in the first attempt, so you've hit jackpot. If you don't, nothing to worry about. This method, by the way, another name of this method is called trial and error. So doing a bit of trial and error is always encouraged. So 8 times 2 is basically what we're looking for. Why? Because if you put the minus sign with 2, 8 plus minus 2, which eventually becomes 8 minus 2, is equals to 6. And that's exactly how we want to break the middle term. So we have x squared plus 8x minus 2x minus 16. In the first pair of terms, we'll take x common, so we have x plus 8. In the next pair of terms, we take minus 2 common, so we have x plus 8 inside the bracket again. So now we're looking at x minus 2 times x plus 8. And this is where you stop. Okay, so number 6. So we have 5x squared plus x minus 4. So this time the product has to be minus 20, because that's what you get when you multiply minus 4 with 5. And the sum you want to be positive 1. So the answer is sort of in the question. Okay, the numbers that you're looking for are sort of in the question. So 5 times minus 4 is minus 20, and that's exactly what you're looking for, because 5 plus minus 4, which eventually becomes 5 minus 4, is equals to positive 1. So you're looking at 5x squared plus 5x. By the way, just to spice things up a little, let's say you change the order and you wrote minus 4x plus 5x minus 4. Okay, let's see what happens now. So as far as 5x squared minus 4x is concerned, what you can take common is x. So you get 5x minus 4. And as far as 5x minus 4 is concerned, there's absolutely nothing you can take common. So you just put a plus 1 here and you write 5x minus 4. And now you're looking at x plus 1 times 5x minus 4 as your final answer, and it made no difference even if you change the order. Okay, so changing the order is it's not going to make a difference to your final answer as long as you don't mess up the signs. Okay, so now we have a different category of questions, and this time what you will notice is that the product and the sum both are negative. So the product is minus 12 times 1, so that's minus 12. And as far as the sum goes, the sum is minus 1, so I'll write it over here. So what do you do when the product and the sum, they're both negative? Well, in that case, you put the minus sign. There has to be a minus sign because that's the only way the product can be negative, but you put it with the larger value. Okay, so what do I mean by that? Two numbers that I can multiply and make 12. Again, we're not so focused on the sign right now, but let's just focus on 12. So 6 times 2 is one option. So that way, if I put minus 6 on 2, minus on 6, the larger value is still negative, and the sum, however, minus 6 plus 2 is minus 4. That's not what we're looking for, so we've got to try something else. Let's try 4 times 3. So again, minus sign with the larger value, and minus 4 plus 3 is equals to minus 1, and this does the job for us. So we're looking at x squared minus 4x plus 3x minus 12. In the first pair of terms, we factor out x, so we're looking at x times x minus 4. In the next pair of terms, we factor out 3, so we're looking at 3 times x minus 4. And now we have x plus 3 times x minus 4. Okay, this is one question that I would like you guys to try yourself, and you can reach out to me on Instagram, show me your solution, and get it verified by me. Okay, I'll leave a link to my Instagram in the description. Feel free to reach out. So question number 9, however, is one question that I would like to solve for you guys. So let's see how this works. Okay, so the product is minus 7 times 4, so that's 28. Okay, I'll minus 28. I'll highlight it for you guys. So minus 7 times 4. The sum is minus 12. So two numbers that you can multiply and make 28. Okay, so let's do a bit of trial and error. 7 times 4. Minus sign with 7, but that's not going to do us any good. Let's do 14 times 2. This should work because minus 14 plus 2 is equals to minus 12, and there you go. So we're looking at 4x squared minus 14x plus 2x minus 7. So what should you factor out from 4x squared minus 14? Well, they're both even, so that means they're both multiples of 2, and we can also factor out x. So you're looking at 2x minus 7. And then in the next pair of terms, there's absolutely nothing that you can factor out, so you'll just write plus 1 and then 2x minus 7. So you're looking at 2x plus 1 times 2x minus 7, and again, this is the point where you stop. Okay, and now I come to the third and the final category of questions where you have the product. So let's see what the product here is. The product is basically 6 times 1, okay, so that's 6 positive. The sum, however, is minus 5, okay. Now this means that the product is positive, the sum is negative. Now where exactly do you put the minus sign? Where do you put the minus sign? With both the terms. Okay, let me show you what it means. So let's go back here. So two numbers that I can multiply and make 6. Well, 3 times 2 is a good option, okay, but 3 plus 2 gives me 5. Okay, so that's not too good because I'm not checking both the boxes. I'm just checking one box, which is where the product is positive 6. So how about I do minus 3 times minus 2? Well, this way the product is still positive 6, and minus 3 plus minus 2, which eventually becomes minus 3 minus 2, is still minus 5. Okay, so now I'm checking both the boxes, so that means these are the terms that I'm looking for. So we have x squared minus 3x minus 2x plus 6. What do I factor out in the first pair of terms? Just x, so I have x minus 3. What do I factor out in the next pair of terms? Minus 2, so I have x minus 3 again. And now you have x minus 2 times x minus 3 as your final answer. If you understood this, that's great. If you haven't, nothing to worry about. However, I'd still like you guys to try out question number 11. I'm, however, going to do question number 12 to further explain what we just did in question number 10. So this time the product is going to be 3 times 4, so that's 12, and the sum we want to be minus 7. Okay, so 4 times 3 is a good option. Okay, but the problem with that is that 4 plus 3 is equals to 7 positive, and that's not what we're looking for. So that means we have to make sure that we're putting the minus sign with both the terms. So minus 4 plus minus 3, which eventually becomes minus 4 minus 3, and that's equal to minus 7. So we're looking at 4x squared minus 4x minus 3x plus 3. So I can factor out 4x in the first pair of terms. So I'm looking at x minus 1 and then minus 3. So again, I'm looking at x minus 1. And now I have the final answer, which is 4x minus 3 times x minus 1. So yeah, this is something I've been wanting to make a video on for a very long time, and I really hope you guys have understood this. Remember to not forget this table. Okay, take a screenshot of this, do whatever, write it down somewhere, and use it initially. Okay, I don't want you to end up using this way too often. Okay, just use it initially. Once you've understood the concept, then don't use it. Okay, so yeah, like I said, that's all for this video. See you guys in the next one. Until then, take care. Bye bye.